we have to find the solid, volume of the solid that is underneath this, because the integral in 2D gave us the area under the curve, right? So now integral in 3D, of course, gives us volume under the surface. So this is our function. And then our region looks like this. So can you imagine paraboloid coming up here? Well, you don't have to imagine it because I got the picture right here. You get it? This region right here looks like that one from the top. And this is a paraboloid. So we want that volume right there. That you get it? Okay, how can we find it? You don't have to sketch this, but you should sketch this one. Okay, now we have to figure this thingy out. Well, the volume, of course, is the height, right? So my dv, of course, is f of x. Let's start writing it here. dv will be, of course, f of x, y, and then times dA, you know what I'm saying? And dA, of course, is dx dy or dy dx, something like that. That's my dA, and dA, of course, is this tiny little rectangle right here. So far, so good? Okay, now what is that arrow doing here? Imagine you're writing a computer program. Okay, now you have to build this. I'm going to zoom in super close, and this is like first rectangle here, and then it will be a French fries with a height which is 0, and then next one you're going to put it here, and then you're going to put it here, and then you stop. Next one you put it here, here, and here, and you stop when you hit that curve. You know what I'm saying? Do you see this process going on? And then you stop right here. So the lower limit and upper limit is not from 0 to 4, is it? Do you see that? Okay, so our volume then becomes general f of xy, and then dA, well, dy, dx. I'm going to put this one as dA, and dy dx. Let's say then we have to decide which variable we want to integrate first. Up to this point, it didn't matter. If you switch this variable, you just switch the limits of integration, right? So it didn't matter. But now it does a lot. So I'm going to call this thingy y1 and y2, right? So what we have to do is we have to integrate this thing from y1 to y2. Do you understand that part? Okay, y1 being, let's call this thing g of x. This is g. And this, let's say, is h of x. Why am I writing it here? Let's say g of x is equal to this one, and this is h of x. So from function to function. Do you understand this writing? Right, because we're stacking these little rectangles up from bottom to up, and then we are continuing this process. So next one will be here. Like that. You know what I'm saying? That's what that arrow signifies. So starting point is right there and ending point is right there. You know what I'm saying? Within that column. Having said that, then how many columns does there exist is the next integral. That's from A to B. So in our case, this thing becomes from y is equal to x squared to y is equal to 2x. I'm writing it like that. It's like y1, y2, if you will. y1 and y2, okay, of our paraboloid, which is x squared plus y squared. And then the y, good. And then x will vary from 0 to 2, and the x. This setup is critical. Don't try to memorize it. Do you kind of get it? And if you don't, now is really good time to ask. After this, it's all downhill. You with me? Okay, then we evaluate. So from inside out, and we cannot just switch this now anymore. Actually, there's a way to switch it, and some tests actually, I remember taking a test on this subject, rewrite the integral, like what, right? And then we are going to do that. We are going to switch order of x and y in the next, I mean, the same thing, but we are going to do that too, okay? So we evaluate that integral. So we are holding x as a constant, so we'll pick up x squared y plus and then y cubed, therefore 1/3. And this is from y is equal to x squared to y is equal to 2x and dx. You with me? Say yes, say something so I understand you got this or not. Now we substitute. So we substitute this thingy to both of them, right? So what we have is 2x cubed now, right? Substituting 2x. And then here is 1/3, 2x, so 8/3, x cubed. With me? And then substitute x squared minus, so x squared here, so we have x to the 4th power. And then here, minus 1/3. So x to the 5th power over, wait, x to the 6th power over 3, 8. I'm gonna write 1/6 first, and then x to the 6th power, and then dx. So it becomes a single integral now. And this is confusing stuff. So like, let me know right now if you're confused about it. Okay, then now it's downhill. We know what to do. We integrate. Is there anything? Yeah, we should simplify before we integrate. So 0 to 2. And this thing, is it 14/3? X cubed minus x to the 4th power minus 1/6 x to the 6th power, and then dx. Good. Now integrate. So each integral becomes really lengthy. So this is x to the 4th power, right? So therefore 7/6, reducing to, okay, minus this thing x to the 5th power, therefore 1/5, and minus x to the 7th power, so therefore 140, wait, what is it?
I think instead of 1/6, I think it was supposed to be 1/3.
Was it one? Oh my god, why did I put 1/6? Nice catch. So this is 1/3, which means 21 now, right? From 0 to 2. And this is the most difficult part. Can somebody tell me what that's supposed to be? Okay, it's too much algebra, so we do it in our head. 216/35 is what I got from the book. I mean, in my head. Okay, and this, usually in this business, this final answer is very nasty because of all this integration, right? Now we'll do it in the other direction now. What about if we want to integrate with respect to x first? Okay, I have another one queued up here. I'm gonna move this one up a little bit. Did it move? Move. Okay. This time, forget that letter. I'm gonna move it this way. What does that look like? Okay. So same dB. So my v here will look like double integral, and integrand is still the same, x squared plus y squared. But I want to do dx first, then dy second. Right? Then we cannot just switch this thing and say 0 to 2 and then x squared and then 2x. We cannot do that. Okay, so let's set this thing up correctly. So imagine if you're moving it, stacking this thing sideways, and then you stop here. You draw that one, and these things have columns, French fries, right? You're going to move that way, and then calculate the height, and then multiply by that dA. You know what I'm saying? If you're a programmer. So this is your starting point, and then you're going to side. So this is your starting point, and this is your ending point, isn't it? So we have to write the inverse functions of these two. So here I'm going to call this one x1. x1 will be y over 2, right? And here x2 will be square root y. How about that? You with me? So the inner integral, it has to start from a function and end it at a function. You get it? So here I'm going to put x1 is equal to y over 2. And here x2 is equal to square root y. How about that? Do you agree with this setup? And then my y variable will start from 0 to all the way up here, which is 4. Meaning these columns, these rows of the rectangles will go from down here to up there. Think of it as a nested for loop. Those of you who took comp sci, you guys know what nested for loop is, right? So this is outer loop and this is inner loop. You get it? Right, you really have to write a program to understand this, but I think this will do. If you're confused, now is a good time. Okay, then. That's equal to 0 to 4. Now we evaluate with respect to x first. So this becomes x cubed, therefore 1/3. That 3 looks weird. Therefore 1/3. That still looks weird. Wow, what is wrong with my writing today? Plus and x y squared. You with me? And then starts from x is equal to y over 2, x1, x2 is equal to square root y, and then we still have dy. Now you don't have to really write x is equal to x is equal to. People just write these things all the time. But I just, like, for the first time, for newbies, I wanted to make sure what's going on. What do you plug in for what? Okay, so we have 0 to 4. Now we plug it in, right? So square root gets plugged in here, so that should be 1/3. Is it 3 over 2 power then? Good. This is 1/2 power, plug it in. Plus, and then you plug it in here to x, not to y. So this is 2.5 power, right? Good. This is 5. That doesn't look like 5 now, does it? Good. Okay, minus, and then you plug it in, plug this thing in here, so cube, so 8, so 1 over 24, and then y to the 4th power, wait, y cube. Good? With me? And then you plug it in here, so that's y to the 4th power, but we have to, yeah, wait, here, so y is still cubed. So we have minus 1/2 y cubed, and then dy. So far with me? Let's simplify this. So 0 to 4, and these are not the like terms, so we have 1/3 y 3/2 plus y to the 5/2, and these two, u 12, is it 13/24? Right? And then y cubed. With me? Okay, now we integrate. So we have y to the 5/2. So 2/5, 2/15, plus, and this becomes y to the 7/2. So therefore 2/7. And this is a headache one. This becomes y to the, oh, actually not that bad, right? 4s and divide. So you, right? What is this? Divide 13 over
96.
96. Thank you. Okay, from 0 to 4, and this part 216 over 35. How's that?